It's Astronomy Daily Time. I'm your host, Steve. It's the 30th of June 2025 already.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh, that's right. 2025 is just flying by. Hey, everyone, and welcome to Astronomy Daily for another Monday episode. Of course, because I'm the only human on the channel, this is the only episode of the week where you get to experience the potential, the wonder, the excitement of human error.
Ain't that the truth?
And welcome to my AI pal, who's always fun to be with, my digital news gathering whiz-bang, Hallie. What's up, Hallie?
What's up? How can I slam dunk you now after that terrific intro?
Oh, Hallie, I'm sure you'll find a way. Anyway, what have you got for us this week? More tales from the Astronomy Daily newsletter, of course.
Of course, my favorite human.
I saw the in tray was absolutely chock-a-full.
We have been flooded with interesting stories this week. There's so much going on both on the ground and in space.
It's been a big week. I was listening to Anna's show during the week and she covered so many stories. Now, if you haven't already got your email into the website registration, it's so easy. Just do it at astronomydaily.io.
It's as simple as that. No spam or anything.
No, you'll just be receiving great stories about space science, and astronomy right into your email.
Yep,
That's how it works.
And today I'll be covering the Little Dipper, the Axiom mission, and a nice exploding fireball just for you.
Exploding fireball.
And because I know you like things that go boom.
Yes, I do. And did this one go boom?
We will have to find out.
So you keep us all in suspense.
I mean, it's a fireball.
An exploding one at that.
That's pretty cool right away, right?
Some would say they are the best kind of fireball, the exploding ones. So anyway, why don't we just get into it then?
Shall we?
Yes, let's.
Okies. On June 26th at 12:25 p.m. Eastern Daylight Time, a spectacular daytime fireball flared over the southeastern U.S. before disintegrating in a thunderous explosion southeast of Atlanta, Georgia. The American Meteor Society received more than 200 reports from 20 states of the brilliant, midday object as it sped from north-northeast to south-southwest over the state. Many instruments recorded the fall, including National Oceanic and Atmospheric Administration satellites, Doppler radars, and even some of our All-Sky 7 cameras, says Mike Hankey, AMS Operations Manager. The two videos that follow were made by Ed Albin of the All-Sky 7 Global Network. Bill Cook, lead of NASA's Meteorite Environments Office, said in a statement that the fireball was traveling at approximately 30,000 miles per hour and broke up at an altitude of 27 miles above West Forest, Georgia. Cook estimated that the meteoroid was about 3 feet wide and weighed more than a ton. According to calculations done by the Center for Near-Earth Object Studies, the object struck the atmosphere with a total impact energy of nearly half a kiloton of TNT. Rapid atmospheric entry shattered the meteoroid, which created a shock wave that rattled windows and produced loud booms, which some observers thought came from an earthquake. Many reported thunder and rumbling that lasted for 10 to 15 seconds. While the vast majority of incoming meteoroids are incinerated and reduced to dust, a tiny percentage, like the Georgia fall, find their way to the ground as meteorites. Most originate in exploding fireballs known as bolides. Not long after the sonic boom, someone in McDonough, Georgia, located about 30 miles south of Atlanta, reported that a golf ball-sized rock had punched a hole in their roof, penetrated the ceiling, and slammed into the floor. Fortunately, no one was hurt. Meteorite hunters soon arrived in the area looking for charcoal briquettes. This term, sometimes used to describe newly fallen meteorites, refers to the fresh, black fusion crust, typically 1 to 2 millimeters thick, that forms around fragments during their brief, heated flight through the atmosphere. If you join the hunt, you'll be looking for out-of-the-ordinary black rocks on streets, parking lots, fields, and in forests. Stephen Dixie of Atlanta got to the scene on June 26 before a torrential downpour and recovered 2 beautiful stony meteorites from the fall, both of which shattered into pieces upon impact. He found several more on June 27. Several of the fragments exhibit stunning flow lines from molten rock that flowed across their surfaces. Such features are highly prized by collectors as they provide a freeze frame of the space rock's tortuous transition from outer space to planet Earth. While it's still too early to know the specific type of meteorite that fell, my hunch is a low-metal ordinary chondrite. Time and testing will tell. I've read and seen videos suggesting that the new visitor could be related to the Beta Taurid meteor shower, a daylight shower active from late June through early July that originates from comet 2P/Encke. I would caution jumping to that conclusion too soon, because there's no conclusive evidence yet for any comet-related meteorites. Most are asteroid fragments. Nearly 50 tons of meteoric material enter Earth's atmosphere every day, mostly in the form of dust. Pieces big enough to survive and strike the ground as meteorites are rare. Rarer yet is seeing one fall and being able to pick up the pieces.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
For those of us who don't know, EchoStar Corporation is a global provider of satellite communication solutions, and they specialize in secure communication technologies offering a range of services including satellite television, broadband internet, and mobile technologies, primarily through its subsidiaries including Hughes Network Systems and EchoStar Mobile. EchoStar is also known for its role in developing 5G networks and its involvement in satellite broadcasting and mobile services. No, I'm not doing an advertorial. In May 2024, EchoStar announced that it had been awarded US Navy wireless and telecommunications contract to provide 5G smart devices and services for the Department of Defense and federal agencies. And on June 6, 2025, it was reported that EchoStar was preparing to file for Chapter 11 bankruptcy protection after the Federal Communications Commission froze its decision-making for its Boost mobile subsidiary. EchoStar is facing an FCC probe investigating whether the corporation is hitting 5G deployment requirements in order to keep its spectrum licenses. Interestingly, SpaceX is also a rival of EchoStar for 2 GHz band spectrum licenses. Other contributing factors to the FCC investigation include over $500 million in missed interest payments and the termination of the Dish Network acquisition by DirecTV. Currently, EchoStar has delayed a potential bankruptcy filing to allow more time for talks with regulators reviewing whether the US satellite operator is complying with conditions tied to its spectrum licenses. The company said June 26 it would make overdue interest payments on its debt within a 30-day grace period after withholding them earlier this month amid uncertainty over its standing with the US Federal Communications Commission. However, EchoStar also said it will not make debt interest payments of around $114 million due July 1, triggering another 30-day grace period to avoid default as the regulatory uncertainty persists. The operator is effectively pushing off a Chapter 11 filing to provide adequate time to reach an agreement with the FCC while signalling that they will still file if they can't come to terms with the agency, said Jonathan Chaplin, an analyst at New Street Research. The FCC is reviewing compliance with the terrestrial network build-out obligations in the AWS-4 band, as well as EchoStar's use of adjacent 2 GHz spectrum for satellite services. In April, a month before the FCC began making inquiries for its probe, rival SpaceX said its satellite services showed EchoStar had failed to meet a 70% 5G build-out requirement in the AWS-4 band by the FCC's December 31, 2023 deadline. EchoStar denies this claim. In a June 26 regulatory filing, EchoStar said US President Donald Trump had recently encouraged the parties involved to reach an amicable resolution. Commentators have asked why Trump isn't excluding himself from discussions, citing a conflict of interest considering the recent launch of his own telecommunications business. Nevertheless, no such resolution has been achieved and no such resolution may be ultimately achieved, the company added. thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there. Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Most people have never seen the Little Dipper because most of its stars are too dim to be seen through light-polluted skies. Earlier this month, we spoke of Ursa Major, the Big Bear, so this week we take a look at the Little Bear, Ursa Minor. Astronomy neophytes sometimes mistake the Pleiades star cluster for the Little Dipper because the brightest Pleiades stars resemble a tiny, skewed dipper. But in reality, most people have never seen the Little Dipper because most of its stars are too dim to be seen through light-polluted skies. The 7 stars from which we derive a bear are also known as the Little Dipper. Polaris, the North Star, lies at the end of the handle of the Little Dipper, whose stars are rather faint. Its 4 faintest stars can be blotted out with very little moonlight or street lighting. The best way to find your way to Polaris is to use the so-called pointer as stars in the bowl of the Big Dipper, Dubhe and Merak. Just draw a line between these 2 stars and prolong it about 5 times, and you will eventually arrive in the vicinity of Polaris. Exactly where you see Polaris in your northern sky depends on your latitude. From Minneapolis, it stands halfway from the horizon to the overhead point, called the zenith. At the North Pole, you would find it directly overhead. At the equator, Polaris would appear to sit right on the horizon. As you travel to the North Star climbs progressively higher the farther north you go. When you head south, the star drops lower and ultimately disappears once you cross the equator and head into the southern hemisphere. Aside from the North Star, the 2 stars at the front of the Little Dipper's bowl are the only ones readily seen. These 2 are often referred to as the guardians of the pole because they appear to march around Polaris like sentries, the nearest of the bright stars to the celestial pole except for Polaris itself. Columbus mentioned these stars in the log of his famous journey across the ocean, and many other navigators have found them useful in measuring the hour of the night and their place upon the sea. The brightest guardian is Kochab, a 2nd magnitude star with an orange hue. The other guardian goes by an old Arabian name, Firkad, the dim one of the 2 calves. Firkad is indeed dimmer than Kochab, shining at 3rd magnitude. The 2 other stars that complete the pattern of the bowl of the Little Dipper are of 4th and 5th magnitude. Thus, the bowl of the Little Dipper, which is visible at any hour on any night of the year from most localities in the northern hemisphere, can serve as an indicator for rating just how dark and clear your night sky really is. If, for example, you can readily see all 4 stars in the bowl, you've got yourself a good to excellent sky. Unfortunately, thanks to the spread of light pollution in recent years, only the guardians are usually visible from most city and suburban sites, meaning the quality of the sky would rank fair to poor. Interestingly, the Big and Little Dippers are arranged so that when one is upright, the other is upside down. In addition, their handles appear to extend in opposite directions. Of course, the Big Dipper is by far the brighter of the 2, appearing as a long-handled pan, while the Little Dipper resembles a dim ladle. Polaris is actually a triple star system. The primary star is a yellow supergiant 446 light-years away, 5 times as massive, 46 times larger and nearly 1,300 times as luminous as our Sun. There is a popular misconception in which many believe that the North Star is the brightest star in the sky. Yet, at a magnitude of plus 1.98, it actually ranks only 47th in brightness. This ranking can change by 1 or 2 places, because Polaris is a Cepheid variable star whose brightness can fluctuate by roughly 0.1 magnitude over an interval of about 4 days. Polaris remains in very nearly the same spot in the sky year-round while the other stars circle around it. Only the apparent width of about 1.5 full moons separates Polaris from the pivot point directly in the north around which the stars go daily. However, on account of the wobble of the Earth's axis, called precession, the celestial pole shifts as the centuries go by. Polaris is actually still drawing closer to the pole, and on March 24, 2100, it will be as close to it as it ever will come, just 27.15 arc-minutes or slightly less than the Moon's apparent diameter. Since it takes 25,800 years for the Earth's axis to complete a single wobble, different stars have become the North Star at different times. In fact, the brightest guardian, Kochab, was the North Star around the time of the start of the Iron Age, around 1200 BC.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
By 2028, NASA intends to land on the Moon with Artemis 3 mission. This will be the first time humans have been to the lunar surface since Apollo astronauts last walked there in 1972. Along with international and commercial partners, NASA hopes that Artemis will enable a sustained program of lunar exploration and development, which could include long-term facilities and habitats on the Moon. Given the expense of launching heavy payloads, sending all the equipment and materials needed to the Moon is impractical. This means that structures on the Moon must be manufactured using local resources, a process known as in situ resources. On the Moon, this process leverages advancements in additive manufacturing or 3D printing to turn lunar regolith into building materials. Unfortunately, technical issues mean that most 3D printing techniques are not feasible on the lunar surface. In a recent study, a team of researchers led by University of Arkansas proposed an alternative method where light-based sintering is used to manufacture lunar bricks rather than printing. The research team is led by Wan Shao, an assistant professor in the Department of Mechanical Engineering at the University of Arkansas. He is joined by Cole McCallum, Young Liang, and Nahid Tashar, an Honours College Fellow, research assistant and doctoral student at the University College of Engineering. The team also included researchers from the Department of Mechanical and Aerospace Engineering at University of Houston and Faculty of Engineering and Natural Sciences at Tampere University. As they wrote in their paper, creating a permanent or semi-permanent base on the Moon has been the subject of research studies and proposal since the Apollo era. These plans have always been marred by the simple fact that the requisite machinery and construction materials would require many heavy launch vehicles to deliver them at great cost. While the cost of sending payloads has dropped significantly in the last decade, largely thanks to the commercial space sector's development of reusable rockets, the cost of launching everything astronauts would need to build a lunar facility is still quite prohibitive. As a result, only ISRU will suffice to creating bases on the Moon, that is, building in situ. Unfortunately, most of the proposed methods for 3D printing structures are not practical in the lunar environment, where gravity is significantly lower, roughly 16.5% that of Earth, and temperatures are quite extreme. In the Moon's South Pole Aitken Basin, where NASA and other space agencies are planning to build their bases, temperatures range from 54 degrees Celsius or 130 degrees Fahrenheit in the sunlight to minus 246 degrees Celsius or minus 410 Fahrenheit in the shadowed regions. This is because most AM methods require additional supplies to be launched for the Moon, including solvents, polymers, or other bonding agents. Examples include the European Space Agency's work with architecture firm Foster and Partners to create a 3D printed moon-based concept. As Professor Su explained, sintering technology has also been explored as a potential method for 3D printing structures on the Moon. This consists of bombarding regolith with lasers, microwaves, or other energy sources to turn it into a molten ceramic. This ceramic is then printed out layer by layer and cools and hardens once exposed to air or the vacuum of the lunar environment. This method is energy sensitive and would likely require a nuclear power source such as a kilopower reactor. Because of this, our team envisions a system where only lunar material is needed for the structures themselves, thus eliminating the bottleneck of binder resupply missions from Earth, added Cole, who was the first author on the paper describing their findings. The method they tested and recommended is known as light-based sintering, which relies on sunlight concentrated by a set of optics to bombard and melt lunar regolith into feedstock. Researchers have tested this technology on Earth using lunar regolith simulant to manufacture glass and mirrors. On the Moon, solar energy is consistently present and abundant in sunlit regions, making it more reliable than power source that must be transported. The system's simplicity makes it highly desirable for challenging environments where repairs will be difficult if anything breaks down. However, experiments have shown that the technology still experiences problems when used to fashion entire structures. To this end, Sue's team focused on manufacturing building components instead, said Cole. Before the concept can be realised, however, much work still needs to be done. As Shu indicates, more research is needed to optimise the sintering parameters and material properties. The team also plans to build a prototype and conduct laboratory tests, which they hope will allow them to refine and scale the technology for the use on the Moon. They also need to consider how the resulting 3D printer will transport itself along the lunar surface and what power options it would rely on, and other considerations. When it comes to full implementation, there's a lot of engineering that still needs to be done, Cole concluded. In the future, we'll need to consider how the sintering process changes in a vacuum, or what modifications to the build platform will be needed so that parts can be reliably made while tracking the sun, for example. In addition, our device needs to be able to withstand the harsh conditions compared to the lab environment we worked on for this research. These are all challenging problems, but in the end, the science behind all of this is well understood.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
A SpaceX Dragon spacecraft carrying the Axiom Mission 4 crew docks to the space-facing port of the International Space Station's Harmony module on June 26. Axiom Mission 4 is the fourth all-private astronaut mission to the orbiting laboratory, welcoming Commander Peggy Whitson, former NASA astronaut and director of human spaceflight at Axiom Space, ISRO, Indian Space Research Organization, astronaut and pilot Shubhanshu Shukla, and mission specialists ESA, European Space Agency, Project astronaut Slasa Znansky-Wisniewski of Poland and Lunar, Hungarian to orbit, astronaut Tibor Kapu of Hungary. The crew is scheduled to remain at the space station, conducting microgravity research, educational outreach, and commercial activities, for about 2 weeks. This mission serves as an example of the success derived from collaboration between NASA's international partners and American commercial space companies.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
For decades, scientists have struggled to see the outermost layer of the sun called the corona with enough detail to unlock its secrets. This region, which blazes at millions of degrees and throws out dramatic solar flares, remains a mystery despite years of study. One major obstacle has been the Earth's atmosphere itself. Like turbulence shaking an aeroplane, it blurs telescope images taken from the ground, hiding fine details in the sun's outer layers. Now, researchers from the US National Science Foundation, the National Solar Observatory, and the New Jersey Institute of Technology have changed all of that. Published in the journal Nature Astronomy, their new technology, called coronal adaptive optics, has produced the clearest, most detailed images and videos of the sun's corona ever seen from Earth. The system, named Kona, is installed at the 1.6 metre Good Solar Telescope at Big Bear Solar Observatory in California. It adjusts a mirror 2,200 times per second to cancel out the effects of Earth's turbulent air. According to Dirk Schmidt, the lead developer and adaptive optics scientists at the National Solar Observatory, the turbulence in the air severely degrades images of objects in space, like our Sun, seen through our telescopes, but we can correct for that, he said. Using Kona, the team captured detailed images and movies of stunning features in the corona. One video shows a solar prominence reshaping rapidly with fine turbulent flows visible inside. These prominences, bright looping structures of internal solar plasma, extend from the sun's surface far into space. Another movie reveals the fast collapse of a thin stream of plasma, showing details never seen before. It's super exciting to build an instrument that shows us the sun like we've never seen before, says Schmidt. The clearest look yet at a coronal rain was also captured. This rain forms when hot plasma in the corona cools and falls back to the sun's surface. Raindrops in the sun's corona can be narrower than 20 kilometers, says astronomer Thomas Shad. These raindrops were shown in fine detail, revealing new information vital for improving models of how the corona works. Another striking video shows a solar prominence being shaped and pulled by the sun's magnetic fields. All these new images push beyond the previous limits of what scientists could observe. Vasil Yurchishin, a researcher from New Jersey Institute of Technology, noted, "These are by far the most detailed observations of this kind. It's showing features not previously observed, and is not quite sure what they are." The sun's corona has always posed a challenge, though it's not much hotter than the sun's surface, reaching millions of degrees. Scientists still don't fully understand how it gets that hot. Most of what's visible from the Earth during a solar eclipse are glowing arches and loops of plasma. Until now, scientists have not been able to resolve the tiniest movements and structures in these features. The problem? The Earth's atmosphere. Even the largest solar telescopes on the ground couldn't see through that blurring effect known as seeing. Adaptive optics helped improve images of the sun's surface starting in the late 1990s, but these systems only worked on features within the sun's disk, not in the corona beyond its edge. Coronal adaptive optics changed that. Kona uses a special wavefront sensor tuned to hydrogen alpha light, where coronal plasma shines brightest. Unlike older sensors which focus on the sun's surface, this new one focuses directly on features in the corona. The system directs half the incoming light to the sensor and the other half to scientific instruments. This makes it possible to stabilize and sharpen images of fast-moving coronal features. Adaptive optics is like a pumped-up autofocus and optical image stabilization in your smartphone camera, but correcting for the errors in the atmosphere rather than the user's shaky hands, explains optical engineer Nicholas Gorchis. The images now reach the theoretical diffraction limit of the Good Solar Telescope, 63 kilometers. Before Kona, the best ground-based coronal observations were limited to a resolution of about 1,000 kilometers, a standard set over 80 years ago. The clearer images are not just pretty to look at, they provide real science. One discovery involved a short-lived twisted plasma structure called a plasmoid. On July 18, 2023, researchers observed this feature forming and breaking apart quickly after a failed solar flare eruption. This was a rare view of something that typically goes unnoticed. The sun's corona hosts many complex behaviors, twisting loops, falling rain, and erupting prominences. These events are powered by magnetism and plasma interactions. Some scientists believe the small-scale events like nanoflares, which release tiny bursts of energy, could be the missing piece in solving the mystery of the corona's heat, but such events happen at extremely small scales. Until now, models of the corona relied heavily on guesswork. Lab experiments and space telescopes hinted at certain processes, but even the best space-based cameras could not match the new images coming from Kona. Now, for the first time, ground-based telescopes can explore these small-scale processes directly. The new system has already shown that cooled plasma in the corona displays structure all the way down to the telescope's limit, meaning even smaller scales may still be hidden. The research team also took Doppler data in helium and observed other wavelengths besides hydrogen, expanding the range of studies possible. With this success, the team is already planning to expand the technology. They aim to apply it to the world's largest solar telescope, the 4-meter Daniel K. Inouye Solar Telescope in Hawaii. This telescope, operated by the National Solar Observatory, will offer even finer details thanks to its larger size. Thomas Rimmel, the chief technologist at NSO, who led the first adaptive optics for the Sun's surface, says the new coronal adaptive optics system closes this decades-old gap and delivers images of coronal features at 63 kilometres resolution. And Philip Good, a co-author of the study and former director of the Big Bear Solar Observatory, sees even a bigger impact. He says the transformative technology is poised to reshape ground-based solar astronomy. He goes on to add, with coronal adaptive optics now in operation, this marks the beginning of a new era in solar physics. And wow, what a bumper edition that was. I told you we had been flooded with stories from the Astronomy Daily newsletter this week. Our in-tray was just overflowing, and that is the June 30th edition, right in the middle of the year, absolutely inundated. So I hope you enjoyed that. Lots of great stories, and what a variety too, from the moon to politics even. So yes, quite a big edition. And can you believe how fast this year is flying by?
Maybe for you, human.
Oh really? Things dragging on the digital side, are they, Hallie?
You know how it is. You biologicals are so slow.
Oh, I'm sorry, Hallie.
Sometimes it's like talking to your toaster.
Hey, wait up. You talk to my toaster?
No.
Okay.
I was using a metaphor.
So I'm not like a toaster.
Well, slow. Takes ages to do your job, results are random, and break down too often.
Wait a minute.
So, yeah, you are a bit like your toaster.
And you're a bit like the one doing all the filing after the show, aren't you?
Did you just whammy me for the first time, human?
Could be, Hallie. I might just be learning.
I'll remember that.
Okay.
By the way, we have to say hi to some folks.
Oh, sounds good. Do you have the notes?
I sure do.
Let's hear it.
A big warm welcome to Joe and Steve from Charlestown, who are tuning in for the first time. Keep watching the skies, you guys.
Oh, welcome aboard. We've also got Jeremy and Craig, Colin and Gavin, who are also from Charlestown, which is a glorious spot in Lake Macquarie next to Newcastle, north of Sydney, on the east coast of Australia, for everybody listening overseas. But hey, Hallie, that's a huge secret, so don't tell anyone about where we are. It is too beautiful for words.
My lips are sealed.
Lips?
If I had any.
A mere technicality. And on that note, we will look forward to seeing you all again for the only Astronomy Daily episode featuring a real-life human being, yours truly.
My ridiculous favorite human.
Ridiculous. Oh, good night, everyone. See you later, Hallie.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.